Welcome everyone. So this is our 98th live stream geometry. We have 2 people here with us so far, and today I'm going to go over a couple problems from the Discord Geometry Olympiad. So last time I took some from the Discord Junior Geometry Olympiad, and then I'll do a couple other problems from the Geometry Discussions and Problems Discord server. If we end up finishing those others earlier, or if we just want to move on. So if you'd like to join us in the future, feel free to email me at mgreen801@gmail.com. It's in the description of my video. We meet every Sunday at 8 a.m. US Central Time. All right, so I'll start sharing my screen. All right. So here's the first problem. This is from the GEO individual. Sorry, I probably should have written whether it's individual or not here. And how do I maximize this? Let's see. Yeah, often I have trouble with this maximizing. I haven't found a great way to get it to work. Maybe if I draw something, then it'll work. I don't know. No. Let's see. Yeah, these buttons won't work, unfortunately. Let's see. What if I try it on a different one? See, now it works. Just not this page. There we go. I don't know what I just did, but it worked. All right. So we have a circle and basically an isosceles trapezoid. Okay. So A, B, C, and then D is just what makes it an isosceles trapezoid. All right. I draw AB and then draw the parallel. So that's point D. And AB is less than CD, we're good there. Suppose E is the intersection of AD and BC. Okay, that shouldn't be too hard. All right. So we have a figure like this, very symmetrical. And X and Y, this should be EX is less than EY. In the problem statement, so I'll go fix that. EX is less than EY, and XY passes through E. Okay, so here's, we have some choice on how to draw this. This almost looks like a right angle, but oh well. All right, so this is X and this is Y, and it says suppose that points P and Q lie on BX and CY, so that EP and Q are collinear and PQ is perpendicular to AB. Okay, so we have BX, CY, and then, so we have a lot of choice in this question. We can choose where Y is, and then we can pretty much choose where P is on BX, and we just have to draw perpendicular. Hey, Ravi. Thanks for joining us. So we just started our first question. E, P, and Q are collinear. Okay, so we can't just make P wherever we want it. We got confused there. All right. Interesting. Okay, so this is P, and this is Q. And we could draw the midpoints of A, B, and B, C because it passes through that line. All right. QX, sorry, I'll read the chat in just a second. QX and BD meets at U. Just gonna make this look a little nicer. So, okay, QX and BB meet at U. And PY and AC meet at V. That's a little bit of a tricky figure, but not the worst. How should I move things so that these are a little farther apart? So that's U. This is V. And we want to show BV, CU, and XY are concurrent. Interesting. All right. So we could just call that intersection point. Why not call it H? And now we'll check the chat. Okay, yeah, BGO individual. All right. Let's see, how do I make a good diagram? Obviously we have I was gonna say we have harmonic quads, but not really, because we don't have tangents. I don't know if it would help to draw the tangents from E. So yeah, BV and CU, we want to show they concur at XY. Okay. Whoops. That. And this. Online Math Club. Who is Online Math Club? Hello, thanks for joining. So, yeah, feel free to share. Yeah, Online Math Club. Ravi, do you know? Oh, Pranav.
Yeah, I should have edited that. Like, I joined with the wrong account.
All right. Good to see you. Thanks for joining us. All right, so this is our first problem. And yeah, so ABCD is an isosceles trapezoid. We kind of complete the quadrilateral. So H is the intersection of the diagonals. E is the intersection of these two sides. And Y is arbitrary. So EY intersects the circle at X. And then we draw this line and we see where BX and CY meet it at P and Q, and then we just complete the figure to make Q and V. And then we want to show BV and CU meet on this line XY. Maybe one way to do it is to show that BV, like find the ratio that BV cuts XY in, and then show that it would be the same for CU. It's one way to do it. Let me try that. So BV meets it at a point I. Can we calculate XI over YI? Let's see. maybe we could find the cross ratio EXIY. So if we project through B, let's think about this. So I guess one thing we could do is, yeah, we could take EXIY and we could try to project it onto this line. Or we could also try to project it onto this vertical line. I kind of like the idea of project it onto this line. So that's JPVY. Okay. Even projecting onto the circle would make sense. Yeah, actually, yeah, I kind of like that idea. Yeah. So we could see where this meets the circle. And then we basically want to find the cross ratio CXYJ. And we want to show, okay, so then if we do it the other way, and you might have just written this in the chat right now, let's see. But, okay, so that's BV. If we did the same thing with point C, like we don't know these concur actually, but we would want to show those two cross ratios are equal. Okay. So yeah, let's just draw one of them for now and then see what calculations we can do with that. Maybe EJ is tangent to circle. I don't think it is, but it's worth checking. Almost looks like that tangent is parallel, which would mean J is
like J is midpoint of AD.
Oh, J is the midpoint of AD.
Not sure, like if they're parallel, like it should be the midpoint, right?
Yeah, if they're parallel, it should be the midpoint. Yeah.
Maybe vary Y, like.
Yeah. Let's move Y. Oh, they're not. Yeah. All right. One sec. Let me get a drink. Check the chat. A and B are basically not important. Yeah, that's true. It's a good point. Yeah.
Almost. We need it actually for U and V.
Oh, yeah, that's true. Yeah, we still need them. Okay, so EXIY. We could try projecting those through A onto the circle. I wonder, yeah. I thought maybe that might be the midpoint, but no. Let's see, is there anything special about point K? I don't think so. I'm going to try also drawing let's see, if I draw this thing I could project through point P onto the circle. What was my other idea? Oh, through point B onto this line. Okay.
Is EUV collinear?
EU and V? That's a
Yeah.
good question. Ah, it looks like they are. Let me check. Sorry, I don't know why it's making it hard on me. Yeah, good
Yeah.
point. So yeah, EU and V are collinear. Not sure why, but it's a good observation. All right.
Maybe like that will make projecting a bit easier. That was the point.
Yeah. Okay. Maybe we could prove that with Pascal's. So let's think about that.
Yeah, that would make sense because like everything is just linked with ABC. No.
Yeah.
Okay. It's not great. But yeah, possibly should be because like they are just linked with ABCDXY, right? Like no other thing is required.
Wait, say that one more time.
Oh, okay. You need P and Q also to define U and V. Okay.
Yeah. XVB and CUY are perspective. So we have XVB and CUY. Let me think about that. Okay, it's the same as showing XVB and CUY are perspective, and so are you saying like we could try like extending things and seeing if 3 points are collinear? So like, did you know? So yeah, so basically, like showing that EV and U are collinear is equivalent to showing those are perspective. Yeah, like we still have to prove their perspective, right? So like we would need to see like where these intersect. Let me think about this. Yeah, that might be a little tricky because like we'd have to see where does CU intersect. Oh, are CU and I collinear? That seems CU and I are collinear. So well, we're trying to prove that they're collinear. Yeah. So that's the problem actually. So we have CU and BV. Maybe if we intersect XV and YU, it'll be some kind of special point. So basically, the thing that we're trying to prove is the point of concurrency. We want to show that this, yeah, I feel like it might be a little hard to show. Oh, it almost looks like these are collinear. Wait, let's.
Is IH parallel to CD?
Is IH parallel to CD?
Yeah, like it looks so. Not sure.
Yeah, it looks like. Yeah, it looks like all these points are parallel to CD. So all those. Yeah, this is interesting.
Oh, if like IH is parallel to CD, then like the harmonic ratio we were taking like EXIY with some constant factor, we can like move it to like EPHQ, which might be like easier to calculate, right?
Yeah. So yeah, it looks like IH is parallel. So yeah, you said you could project it. EXIY through.
Maybe not really project, but like that ratio should be like equal, right?
Yeah. Now, and it's also interesting that all these points are also on that parallel line. So yeah. So I drew a lot here, but I think it might be helpful. Okay, let me make this a little neater. So BX, why did I draw this? Okay, I'm gonna delete this. Delete that. I'm not sure why I drew this. Oh, because I wanted that intersection point, but okay, so YG and XF. We don't need this whole line. Wait, where did those other, oh, actually, yeah, YG and XF, I'm gonna draw. And those look like they also meet. So yeah, a lot of things in this diagram that look true, but we still have to prove. Let I be the intersection of XY with the parallel through H. Yeah, so yeah, let's do that. I agree. I like that. So are X, Y, I, and E harmonic? Good question. So let's think about that. We could check that this way. It looks.
Oh yes, it should be harmonic, right? Because like that line is the parallel and like perpendicular. So like it's like isosceles trapezium, right? So that parallel line through H passes through the intersection of tangents.
Yeah. So the parallel line through H passes through the point of tangency.
It's like it should be harmonic. But we have to prove.
Well, so why does sorry, this is probably obvious, but why does the parallel through H pass through the points of tangent?
Oh, H and that point, ER inverse, right? With respect to the circumcircle.
Oh yeah.
Yeah, like that line, this line is polar of E.
Okay. Oh yeah, it's kind of like a degenerate case of Brocard's theorem, I guess, right?
Yeah. Yes.
So yeah, basically, yeah, we could do it the other way, like you said, where we draw the parallel, and then we want to show B, V, and I are collinear.
Also, like this way, if we like define I to be this way, we already know that that cross ratio is 1 or -1.
Yeah, so we know that this cross ratio is -1. I just happen to see that these concur on that polar. I don't know if it's useful, or how to prove it, but yeah. E, H, P, and Q are harmonic. How do you see that? Let me think. E, H, P, and Q are harmonic. That's what you're saying. By projecting through X, Q intersect Y, P. This point. Okay.
But we do not know that if it lies on IH or not, right?
Yeah. Well, yeah. We still don't know if that point lies on IH. Maybe we show it the other way around. First, show that EHPQ is harmonic. So, for example, let's think about that. If E, H, P, and Q are harmonic, could we project those through B? Sorry, it's hard to make more room here. For example, if we project E, H, P, Q, then that should give us the harmonic quadrilateral. C, D, CDX, and this point. Wait, let me think about that. So that means that XJ should pass through the tangents at C and B. Let's check that. Yeah, looks like it. All right. Okay. Maybe it's worth drawing like these points right here. Because then we know that this is a harmonic quadrilateral. XJLY. And maybe we can project that by Brocard on XBCY. Interesting. Okay. XB by Brocard, XB and CY meet on the polar V. So but let's see. So Brocard would have the intersection of CX and BY, right? And that also, wait, is this all obvious? Oh, okay. So both of those points are going to lie on the polar. Ah. So yeah, this gives us a lot of information. Okay. And then also AX, the same argument. I'll just leave it like that. I was going to say, do AX and BY meet on the polar? I think it might be the same idea. Yeah. Actually, I don't know about. Oh, I didn't do point one. I messed up that line. Oops, I already had that. Yeah. So these look like they all lie on the polar. Get rid of point K. All right. I think we're getting close here. Oh, we didn't get too much farther after we figured out these lie on the polar.
Yeah, we got that EHPQ is -1, right?
EHPQ is -1. That's by
Ravi.
yeah, because then you just project like EXIY, you know, that's harmonic.
Yeah, from M.
And then you just project through M. So yeah. Okay, so yeah, EXIY we know is harmonic now. So you just have to show B, V, and I for collinear. Oh yeah, so by Brocard's this, so yeah, these we know intersect on that by Brocard's. So yeah, we have a lot of things, and then these two I'm not as sure, but so this and this, XF and YG. just going to delete those. I don't know why those intersect on the polar, but I don't know if we need that. We know these two. Well, actually, is it that? Sorry, I thought we could just use Brocards, but now I think it's harder than that because this isn't cyclic.
That we also know that Py and Qx intersect on that line on the polar. That is by Pappus theorem.
By Pappus. Okay.
Yeah, since n lies on the polar.
Oh, XPB and YQC. So
Yeah,
okay.
I think we can prove that BQ and CP intersect on polar, and that would finish it.
Okay. Let me draw this. Yeah, GeoGebra is not going to make it easy for me. I got to zoom in more. Sorry. There we go. All right. So repeat what you just said.
Okay, we would use Pappus's theorem on XPB and YQC.
But we don't have the intersection of PC and QB though, right?
Yeah, but we can do it. It is easy by harmonics, right?
Oh, I see. M, because M and N. So XB and CY intersect at M, and then XC and YB intersect at N, and so therefore the K also lies on.
Yeah.
All right. And then what was the thing you said after that?
Don't know.
Okay. All right. Thanks for joining, Khan. Good to see you again. All right. All right, BV. Hello. So
Okay, I'm not sure if this is true, but is like U the reflection of V over this polar of E? Like, can you draw midpoint of UV? It's true, but not sure. Oh, fine, it's not.
no, because I think we were trying to show UV and E are collinear, and if that's true, then UV is not perpendicular.
Oh, yes. Okay.
Sorry. But yeah, Stefan, you said something, or you're like, I think that would finish the problem, but then I don't know if you forgot what it was. Yes, this is the first problem. So basically, I mean, we know that EXIY is harmonic, so we want to show that BE, BV, or yeah, BE, BX, BV, BY. If we can show that's harmonic, that also solves it, right? And maybe we can project those onto AC. And we get CV, but then we'd have to intersect this. Yeah, there would be a few points that we don't yet know. Like maybe what we could do, we could draw this, and then it's equivalent to showing Y, V, P, and this point are harmonic. that would solve the problem if we could show that YVPR. Oops. And what if we project those through point C? Well, yeah, we wouldn't know where P goes. In fact, if we draw this point, then that's equivalent to showing that SVHC is harmonic. That looks like it shouldn't. SVHC. We want to show that's harmonic. So many things like equivalent. Which is equivalent to showing IKHM is harmonic. And is that obvious? IKHM? I think that's obvious, yeah. Yeah, that's true. IKHM is harmonic, so that solves the problem. Okay, so let me kind of write this backwards. So since IKHM is harmonic, so I'm gonna fill in details here, but so IHKM is harmonic. And that means that if we project through E, that means SVHC is harmonic. No, that's if we project through Y. Then we get SVHC is harmonic, or SHVC. And then once we get that, we could project oh, it's all right. Have a good dinner. Yeah. All right. So SVHC, I forgot what my deal is here. So then we project through Y and we get ER. Now, what do we do after that? I'm trying to remember what my deal was. Okay, so I wanted to show, okay, I think it's R. I wanted to show BR, BP, BV, BY. So I wanted to show RPVY was harmonic. So I could do that by projecting through E. Okay, so this shows that okay, if we project each, it would be YPVR. So this means that I think this works. And that means that BY, BR BV, yeah, BY, BP. So and that means that so yeah, this basically solves it, because then that means Y, X, and then BV intersect X, Y, and E is harmonic. Then, yeah, so I have to write out this proof in detail, but once we know this, then that means BV intersects X, Y, and I. And yeah, you guys can let me know if I'm missing something here, but I think this works. Okay, so let's write this all out. Okay, so by a degenerate form of Brocard on ABCD, the parallel L through H to AB is the polar of E. Okay. So yeah, did we need K? I don't think we need K for this proof. Oh yeah, because we have this as harmonic, so we do need K. Okay. All right. So let L intersect X, Y, and I. And then, yeah, do we need, I feel like a lot of this stuff we don't need, so I'm gonna get rid of it. We can get rid of that. We can get rid of that. We don't really need 0.0. Although it's interesting, but we don't need it. As long as we have this, we're good. So by Brocard's theorem on Y, X, Y, C, B, N also lies on the polar V. So let N be CX intersect BY. And okay, by Brocard on X, Y, C, B. We have N lies on L. All right. And an M. So yeah, let me add M too. Hey, Anurag, thanks for joining. Hello. So M is BX intersects CY. Okay. just going to fix my grammar here just because it's bothering me. Okay, and then let R, well, we could define R. R is YP intersects CE. Although that's kind of obvious from the diagram, but oh. Okay, we have to show that K lies on the polar, but that's true by Pappus. Okay, so K is XQ intersect PY. And I think this does it. Is this everything we need? You think of anything we might have missed? Let's see. Yeah, it's been a while. Yeah, thanks, Anurag. Thanks for returning. Anything I left out here? So, well, I have to show that EXIY is harmonic, but since I lies on the polar, since I lies on L, so since I lies on the polar of L, then YXIE is harmonic. I'll write that. So you just make some room for this. Because yeah, I didn't really write that out. But that's really what I used. So I lies on L. And that means that YXIE is -1. All right. This, I believe, should be everything. Because if YXIE is -1 and we know this is -1, then so yeah, so BV intersects XY at I, and also CU similarly. All right, I think we are good to move on to the next problem. So yeah, this is a lot of Brocard, a lot of fun. All right, so there's this one, and then I had a couple easier ones. And then this one is maybe a little harder. You guys want to try this one really quick? It looks easy, but I'm just kind of curious about it. So maybe we'll just crush it in 2 seconds. But we'll see. So we have a triangle with circumcenter O and orthocenter H. I just feel like crushing a problem. It's been a while since we've done one super quick. So, all right. So O is the circumcenter, H is the orthocenter. Oh, okay. Don't tell us then. Let's see how quickly we can get it. So H is the orthocenter. Oops. And X and Y lie on AB and AC. So that HX is parallel to OB and HY is parallel to OC. All right. So we'll draw some parallels here. So X is on AB and Y is on AC. This is going to be X. and this is going to be y. And we want to show AO bisects XY. All right. Interesting. HX, HY, XY, AO. All right. Let's very simple statement. Maybe we could use projective geometry. So if we draw like the parallel to XY, I'm not sure how much that will help. Because yeah, I don't know what we would do with the parallel to XY. Maybe there's some kind of homothency.
Yeah, H just needs to lie on the altitude by homothency.
Oh, it's true for any point on the altitude?
Yeah, yeah.
Interesting.
You just have a homothency at A.
Yeah, you're right. Good point.
So maybe we can pick some better H.
Yeah, it's a good point. All right, so what's a good point to use?
But where do we send XY to in by taking homothency?
Oh, what?
I'm saying like where will we send XY by taking homothency at A?
Sorry. But yeah, we can use the homothency at A. Yeah, sorry if you said something else other than that. But yeah, maybe there's some other point. So like, oh, where will we send XY to? So what we were thinking is, what Stefan was saying is that H doesn't even, if we can prove it for any point on the altitude, even up besides H, then it would prove it for H also. Because like, let's say, like, let's just pick a random point F on the altitude. So if we did that, then basically F, basically this triangle FGI is homothetic to HXY. So proving that AO bisects XY is the same as showing that it bisects GI. Yeah. So question is just what should that point be? Let's see. So is there a better point than H that we could use? Like we could use the intersection of OC with the altitude, although I don't know how good that is.
What if we think about D to be moving?
Oh, good point.
Then we could send D to O.
All right.
And we will have a nice parallelogram then. So
right.
what was I thinking exactly? You intersect AO with the circle, and you get that is a diameter.
All right.
And then intersections of AB and AC with that line, not the diameter, but the one you already drew in. That would basically make a parallelogram.
Okay.
And with F. And we need then to prove that when you take those two parallels through I and G to OB and OC, you will get then that point lies in altitude. That is what we need to prove.
Okay. So we have to show that.
Not that one.
Oh, sorry.
Parallel to OC at I.
Oh, sorry. Yeah, we have to show that those two parallels lie in altitude. And if we did that, then yeah. Okay, so okay, so first we draw this diameter, and then how do we define this line? Do we just kind of make this line whatever makes it a parallelogram?
Well, you can take G such that GF is parallel to AC.
Oh yeah, good point. So yeah, draw the parallelogram, and then yeah, these are going to meet at O. Yeah, and then we have to show those two parallels concur on altitude. Okay. Send H to E. We could try that, but first, yeah, let me first see if this idea works, because I like this idea. So yeah, we want to show that the parallels at G and I meet on altitude.
We think about like sine Chava on AGI and triangle AGI. I think that we can find sines of those angles really easily.
Yeah, that would probably, yeah, basically sine this over sine this times sine this over sine this, sine this over sine this. That would probably do it. Let me see. I think there's might be we might be able to just use the SARGs or something. Oh yeah, I'm not so sure about the SARGs now, but that would work. Well, maybe because like we have triangle GEI, and then we have A, and then the point at infinity on OC, and the point at infinity on OB. Okay, let me think about sine Cheva. So this over this is obvious. Now this angle here, you know, it's parallel to OB. Let's think about this. So yeah, if we show that XY is parallel to GI, that would also solve it. I'm not sure how easy that is. Well, AG, well, yeah. So we could try to show that AG over AI is AX over AY, and AX over AY, maybe we could use some kind of homothety, because AX over AY is like AX over AH is AB over AJ. and AY over AH is a C over, yeah, so we could probably do, but how do we find AG over AI? Seems like it should be easy, but I don't know. Also, triangles FBG and FIC are like pseudo similar. So like these angles are the same, and these angles are like 180 minus. So that might help. Yeah. So I have ideas. I just think I might be making it harder than it has to be. Like the Trig-Cheva. Yeah.
Maybe we pick some other point.
So like besides using this parallel line, or pick some other point.
Other than F.
Okay.
I don't know. I mean, this looks fairly complicated.
Yeah. I think I have an idea. I just think it might be harder than it has to be. Because like basically here's kind of what my idea was. So if we can show GI is parallel to XY, that solves it, right? And maybe we could do that by showing that AX over AG is AY over AI. And AG is equal to FI and AY is equal to FG. And these two triangles BGF and CIF are like pseudo similar. So that should be
but triangles AIF and BFC are exactly similar. Maybe we can
AIF BFC.
Yeah, so IF over AI, which is AG over AI, is equal to FC over FB.
Okay. So then that makes it easier. And then if we want to do AX over AY, that would be AX over AH divided by AY over AH, and AX over AH. What I was thinking, and maybe there's an easier way to do this. Actually, let me see. Is this cyclic? No. But if we want AX over AH,
you can just use a trig for that. You can AX over AH, you calculate it as sine of AHX over sine of AXH.
yeah.
And that looks fairly simple. You just have, like, it will get like some cosines or something, and that should be computable. Even with this, because this is the diameter, it is also very nice for sines. So I think this is basically done after you just write it.
Okay.
It would work, but like we should try a synthetic approach to it.
Try a synthetic approach.
Electric would definitely work, but we should try a synthetic approach, I guess, because like there would, in my opinion, there would be an easier solution to this problem that way, I guess.
Yeah. So like what I was thinking is, I think so OKJ is isosceles. So basically we have AX over AG, AX over AB is, oh no, I was trying to find AX over AG, but, I was saying AX over AH is AB over AJ, and AY over AH is AC over AK, and this is isosceles So I don't know if that helps at all find AK over AJ. Maybe that's just making it harder. But AK over AJ, I wonder if that's, I mean, AK over AJ, we could kind of use projective geometry. So yeah, maybe we're making this much harder than it needs to be, but if we project AKJ infinity onto BC, then yeah, that's harmonic. So that kind of wait. Actually, yeah, I'm sure there's so many ways to do this, but AH and AO are isogonals. Yeah, so there's so many ways to do this. It's just figuring out the easiest way. I think I might just do this way though. Let's see. HXY and YHA are similar. Oh, really? Okay. I did not realize that. These are similar. Interesting. Yeah, because you could calculate, just do an angle to calculate that. Yeah.
And with that fact, H is actually the Dumpty point of triangle AXY.
Okay. Interesting. So we want to show that this is a median. Okay, basically we want to show this is the symmedian, and if that's the Dumpty point. I mean, we have so many things going on. So yeah, actually I think it's that simple. Basically we could show H is the Dumpty point because we can use an angle chase to show these are similar, and then from there it follows that H is the Dumpty point, and then since these are isogonal, that's a median. So that's probably the fastest way to solve this. Yeah. All right, so I'm going to write that up. So I'm going to delete. I'm sure there's a way to do it with point F. That's easier too. But I'm just going to write this because yeah, that doesn't even use the homothency really. That seems like the simplest solution. Whoops, what did I do there? I just want to delete this. So yeah, we need very little for that. I like that solution because it uses, I like how it uses a lot of theory. So AHX and AHY are similar because we can do an angle chase. So angle AXH is angle ABO. Whoops. ABO is angle BAO. Let's think about this. Which is angle YAH. And then similarly, angle AYH is equal to angle XAH. And that means that, I mean that by itself shows that H is the Dumpty point of AXY. And that means that AH is the median of AXY, which means AO is median. Oh, median. Very cool. So yeah, this seems like the most consolidated solution. All right, you guys want to try this one? I forgot, Stefan, did you say you worked on this one yet?
Yes.
Okay.
And Ravi already solved it.
Okay. All right. Here's a middle riddle. We could try this riddle. So let's see. So we have a triangle ABC.